Hi there, welcome to my super ultra hyper mega awesome midterm review. Today we're gonna be working with a lot of problems that are going to be on most college algebra midterms, and I'm gonna be showing you how to get them out of the way really fast and easy. Now let's begin with polynomials. State whether the function is a polynomial function or not. If it is, give its degree. If it is not, tell why not. So we have 1 plus 11 over x, and we also have 16 x plus 9 times x squared plus 1 times x minus 5, and 4 times x minus 1 to the 12th power times x plus 1 to the 8th power. Now, is the first function a polynomial or not? No, because x is raised to a negative power, because this 11 over x is going to turn into an 11x to the negative 1. Okay? Because remember our rule, 1 over x equals to x to the negative 1. So yeah, that's not a polynomial. Next one. Is it a polynomial? Yes, because it has, yes, it is a polynomial because it has its degrees, right? Degree 1, and this one has a degree 2. Oh, this was squared. Okay, I'm sorry, this was squared. So 2 times 2 equals to 4. This is a degree 4 because we had a square here. So 2 times 2 equals to 4. And we have a degree 1 here. So the degree of this whole polynomial would be 1 plus 4 plus 1, 6. Polynomial, degree 6. Now, last. Which, is this a polynomial function or not? Yes, because we don't have any fractions or negative numbers. Our degrees aren't fractions or negative numbers, so 12 plus 8 equals to 20. Yes, degree 20. Okay, let's move on to another set of problems. Determine the maximum number of turning points of a function. Turning point is the degree minus 1. So you get the degree of the function, and you take away 1, and that's your turning point. So here, our degree is what? 4, right? So 4 minus 1, 3. So you have 3 turning points. 3 turning points. Yeah. That's easy, so let's move on. Form a polynomial function whose zeros and degree are given. We're given our zeros, negative 2 with multiplicity 2, and we're given 0, negative 5, multiplicity 1, degree 3. The degree of the whole thing is 3. So how are we going to get this? We are just going to plot. Let's see how will it turn out. This is a 0, so we put an x, and our 0 we switch its sign, so x plus 2 with a multiplicity 2. Multiplicity is the degree, so x plus 2 squared times x plus 5, multiplicity 1, so multiplicity stays like that, and degree 3, we know that 2 plus 1 equals to 3, right? So here's the degree. So this is our thing, and you're gonna see one of your options, it's gonna look like this. F of x equals to x cubed plus 9x squared plus 24x plus 20. That's gonna be an option that you're gonna have on your midterm. Now you're going to take out your graphing calculator, and you're gonna graph them both. Let's graph the first one. which is x plus 2 squared times x plus 5. We graph it. We can see the graph of f of x. Now you go to y2 and graph your first option, your second option, your third option. But the thing is that you want to get that function over there. You want to get one of your options to be the same graph. Okay? So x cubed plus 9x squared. Oh, wait. Plus 9x squared plus 24x plus 20, and you graph it, and you see that it didn't move, so it must be, so it is the same graph. So that is your answer for that kind of problems. Now let's go to another one. Find the x and y intercepts. Find the x and y intercepts of f. So we're given f of x equals to x squared minus 25 times x plus 2. There you go. What you're going to do is you're going to graph the function, right? Graph the function x squared minus 25 times x plus 2. Here you go. So we graph it. We're looking for the x and y intercepts. So our x intercepts are right there. There's an x intercept at -5, and there's another one at -2, and there's another one at 5. So that's that. Now you go for your y-intercept, you're gonna go to second graph, which is gonna give you the table, and then here you can also see that at 5 there's a 0, and at -2 there's a 0, and at -5 there's a 0. So those are your x-intercepts. Your y-intercept is going to be the number that's next to the 0 on your x. So 0x, y -50. So our y-intercept would be -50. Okay, so we have that our x-intercepts are at -5, -2, and 5. And our y-intercept is at -50. And that's it. That's what you do for those types of problems. Just graph and check the table.